We've got a question here that's given us a probability distribution table, and we need to find out a few things about it. The first thing we need to find out is this e to the x. Now, e to the x is pretty common. It's also the mean. So mu, and the way we write that in funny old Greek language is like this. The sum of x times the probability of x. So what we're going to do is we're going to multiply x times the probability of that outcome, then add it to the product of these two numbers, add it to the product of these two numbers, and these two. So I always find this a little bit scary, but this Greek letter a bit scary. But really, that's all it is. So it'll be 10 times 0.2 plus 5 times 0.06 plus 1 times 0.1 plus negative 1 times 0.82. And that's all we need to do. And if I add those numbers up in my head, what I'll get to is 0.22. The next part of the question asks us to find e of x squared. So I'll do the same process that I've done here, but what I do is I square my x value. So that will be 10 squared times 0.02 plus 5 squared times 0.06 plus 1 squared times 0.1 plus negative 1 squared times 0.82. And then if I do all that, I end up with 4.42. So that's my next one. The third one, so C, e of 2x squared, we're going to follow the same basic process. So it's 2 times 10 squared times 0.2 plus 2, that should be, 2 times 5 squared times 0.06, should be a 0.2 in there as well, shouldn't it? Plus 2 times 1 squared times 0.1 plus 2 times negative 1 squared times 0.82. And that comes out to be 55.56. So hopefully you're getting the hang of the idea of how we do these things. I'll do the last one for you now. So e of 2x plus 5 will be 2 times 10 plus 5, it's exactly as you'd expect really, times 0.02 plus 2 times 5 plus 5 and all that times 0.06 and so on and so on and so on, which will equal 4.56. So that's how we work with these little expressions here. They're quite common in probability, especially e of x, which is the mean.